Phase Change Unit, Lesson 4.1, Introducing the Liquid Oxygen Problem. Activity 3, Modeling Liquid Oxygen Tanks. Next, we'll use the modeling tool to show what happens to oxygen tanks 1 through 3 of the liquid oxygen machine. I'll model what happens to nitrogen in tank 1. Follow along as we walk through the model together. Open the model, nitrogen activity in the modeling tool, and we'll model what happens to nitrogen in tank 1 of the liquid oxygen machine. Drag out two substance descriptions, placing the before box higher along the average kinetic energy bar than the after box. Remember that air is cooled inside tank 1, so energy is transferred out. This means that nitrogen has less kinetic energy after going through tank 1. Open the substance description editor for the before box. Select gas for the phase and low for the attraction level. Nitrogen has a relatively low molecular attraction, just like oxygen and methane. Open the substance description editor for the after box. Choose gas for the phase and low for the attraction level. Remember that the attraction between molecules of a substance never changes. Nitrogen did not change phase in the first tank even though energy was transferred out. Drag out an actual change in kinetic energy arrow and connect the tail end to the horizontal line for the substance description before. Move the arrowhead down until it reaches the second horizontal line. Label the arrow with a B hexagon. This shows that energy was transferred out. Then drag out a change in kinetic energy needed for phase change arrow and connect the tail end to the horizontal line for the substance description before. Move the arrowhead down until it goes past the second horizontal line, indicating that there was not enough change in kinetic energy for the nitrogen to overcome attraction and become a liquid. Label the arrow with a Y square. Now you'll work in groups to model whether oxygen changed phase in the tanks. Each group member will model either tank 1, tank 2, or tank 3. Use the information from the diagrams in the article to model why oxygen either underwent a phase change or did not. Remember to choose the appropriate arrows and labels that best describes your thinking. Find the tank you've been assigned and complete your models. Consider if energy was transferred in or out, if energy was transferred in or out to cause a phase change, why the phase change occurred or did not occur, the roles of energy and attraction, and the ways students can use the arrows to label to indicate the amount of energy change needed for the kinetic energy to overcome attraction or for attraction to overcome kinetic energy. Now that you've made your models, you'll have an opportunity to share your findings with the group. Discuss your models with your group. Begin with tank 1 and then move on to tanks 2 and 3. How do attraction and kinetic energy affect phase change in each tank? End of activity. End of lesson.